Alright, let's take a look at this problem. So in this question, we need to find the arc length of this function from 0 to 3. Basically speaking, if I draw this function, it looks like this, okay? Something like this, okay? And this is the point. Say suppose this is 3, okay? So then you need to find this portion, the length of this portion. Now, we do know that the formula is, first of all, let's check the smoothness, which means y prime exists for all the values in between 0, 3. Okay, let's check the y prime, which is 2 times 3 half x to the 3 half minus 1, which is 1 half. And the 2 and 2 cancel, we are left with 3 square root of x. Well, certainly in this interval 0 to 3, this function is well defined. Therefore, we know this curve is smooth enough. So according to the formula, the L is going to be from, let me clean the screen. I need space to show you the calculation. So the length will be the integral from 0 to 3, square root of 1 plus the derivative of y square. We just show you that the derivative is 3 square root of x dx, right? Okay, so essentially that's what we are trying to find. We need to evaluate this guy. So let's simplify the integrand, which is square root of 1 plus 9x dx, because of there's a square. Now, one thing that if you are able to observe, just by observation, just think about how do you find the square root of x. You're gonna you end up with this 3 half. Actually, it will be 2/3 x raised to power actually 3 half. So this is the antiderivative of square root of x. You can use power rule if you want to go to detail 1 half plus 1, and here this is x raised to power 3 half 1 half plus 1, and that's what I get. So actually the antiderivative of that will be this. I know there's a 9 here. So according to chain rule, when you find the derivative, that I want to have a 1/9 times 2/3, okay? And then here it will be 1 plus 9x raised to power 1 half plus 1, which is 3 half. So this is the antiderivative of this square root of 1 plus 9x. And now again, I treated this, the color is not nice, so I kind of think of this as my u. Basically, I just did some mental math. This is my u. The derivative of u, when in chain rule, it will create a 9 because of the coefficient. That's why I want to use a 1/9 right here, so that it cancels out with the 9, which will come from the chain rule. And so this is the antiderivative, and I'm going to evaluate from 0 to 3, and which gives, so here the constant gives me 2/27. When I plug in 3, I have 1 plus 9 times 3, which is 27. So 27, basically I'll get 28, right? Raised to power 3 half. When I plug in 0, it'll just give me 1. So I check, that seems like this one is my option for the problem that I have. Okay, I'll pick the d. Okay, this is supposed to be right. Now, I certainly want to also show you the chain rule, not chain rule, the substitution. So that's what we have for now, right? Oops, 9x dx. And the 9x is from the square of the derivative, which is the 3 times x, and square, then you get the 9x. So if you want to call u as 1 plus 9x, then du will be 9 dx. So therefore dx is 1 over 9 du. And hopefully you can see that in my previous method I have to include 1/9. That's where the 1/9 come from. And then when x is 0, the u is going to be 1. When x is 3, the u is 1 plus 9 times 3, which is 28. With that, I can now just do the substitution. This will be my square root of u. The dx will be 1/9. So it will be, I'll move out the 1/9, okay? dx. That's my du. So I will do the antiderivative of square root of u, which will be 2/3 u raised to power 3/2. And then plug in 1 and 28. Evaluate at 1 and 28. You'll get to the same answer. So that's my interpretation for this particular problem.